Hey guys, hey everybody, and we have a great day today. Almost no wind because it's early morning Sunday, but I promised for someone of you who asked to get the instructions and settings manual for the JNGE green controller since I've done quite a lot. Let me show you what exactly. I will actually do this. So you may have already seen, or maybe not, that I have been rebuffling my wind part system quite a little. And this is the renewed control board. So, let me give you a little bit of background. So I have this kind of bus bars. This is a 250 amps bus bar. That will be connected, connecting all together, everything. Because you see, there's still a lot of mass because I've been doing all this stuff on preparations. We connecting my lithium ferrum phosphate bank with the gel battery bank, and it will be connecting the small 5 kilowatt day inverter with everything else, with the wind turbines specifically. And what happens is that at this exact moment I have the system on gel running separately. So you see, nothing is connecting the bus bars with everything else. But what goes into bus bars, it gets into here, and then it gets distributed across all the possible modules, all the possible controllers. Of course, I made some marks for myself because I need to understand where which exact one will go, and some of them, as you may clearly see, some of them are on. So what is currently on? This is the JNGE controller. This is the Kherson wind turbine, the Ukraine-made one. This is the gel batteries switch. I consider it as a switch, and this is the white-orange controller that currently FT1000 sits on, because I still don't have all of my wind turbines. Currently I have only 3 in the works, and I meant to have 7 and maybe even more. So yeah, technically, this is spare, and this is spare. So these are currently spare. For this one I have a controller, but I don't have a place to mount a wind turbine, a small wind turbine yet, but technically I have 4 smaller units for spare, and this means that action will happen later on as well. But this is how the new setup will look like. Of course it will be covered, right? The 2 white-orange controllers are meant to be one for FT1000 and the other one for M5. The blue one is out currently of the moment because it will be moved somewhere else. And the green one stays here, but with the renewed configuration. Let's talk a bit about this. The Ukraine-made controller is gone because it's sold. The new one will arrive in probably 2 to 3 weeks, just in time when the wind turbines will arrive, and the LHCM will sit here. This is the place for it. And here technically there might be some kind of small space, but I will need to arrange the resistor somewhere. That will be for Ukraine-made controller to work, to have some space for the extra smaller controllers. But today's topic is this one, is the green controller, the JNGE. Maybe let me switch off the lights. What do you say? Hold on a sec. Yeah, that's much better without a flash at this moment. So this is the JNGE controller, the 1200 watts one for solar and wind. So that's how they state, 1.2 kilowatts. But I have this kind of thing. I have a shunted watt meter, power meter, current meter, voltmeter, whatever, that is currently working in junction with it. And let me tell you briefly about the reason why is it so. So, very simple. This thing can be with Wi-Fi, which in my opinion is absolutely useless because the application behind it is not worth it. So save extra money and just get rid of it. And why, I will explain later, because let's start first with the review button. So by pressing up and down buttons here on this controller, you will be able to circle. Oh, come on, sorry, this is not the default screen. So this is the default screen. By switching up and down, you will be able to circle between, this is the voltage, this is the battery voltage, this is the wind turbine voltage, this is the PV voltage, and then the current that goes from wind turbine, and then the current that goes from PV. Currently it's all zeros because we have no wind and it doesn't have any solar connected to it, just like the batteries. and just the wind turbine input and the dump load, right? So, I mean, this is it. You cannot see any watts. The watts technically you could have seen from the Wi-Fi app, but that app, so, like, I mean, it definitely sucks so much that I stopped using it. I mean, literally, technically, I can tell you that this thing is not required for this kind of controller. Better save that money and get yourself a proper watt meter with Wi-Fi. I have one without Wi-Fi because I don't care about Wi-Fi, but if you want to see what's going on live from anywhere, any place in the world, I will give you the link to this exact good one, which is Tuya application connected, because I have seen that one in controller. That exact same setup, but working one of my subscribers, Ukrainian one, but he has got a Tuya stuff here for the watt meter, and I mean, he can literally see from anywhere in the world how this thing works, and I mean, this is amazing. This is absolutely gorgeous how it works. So yes, that's the connection I will definitely recommend. But in my case, I mean, I'm okay with the standard because I don't care to see any moment live what's going on. Literally, I don't care. I just need the proper watt meter to understand how much per month was produced. So I launched it recently, I mean, in this setup, so that's why there are not that many values. It's 1.7 kilowatt hours only. And I mean, we are in the middle of July, so there is not much wind. So for me, technically, July and August are like dead months, completely, absolutely almost zero wind. It barely rotates, whatever. I mean, the electrics is very simple, so you just like follow the instructions. It's on the back of of that screen, so you just follow it and you will not mess around. But I mean, you need to have a proper shunt for this to make it working absolutely nicely. It is technically variable in 50 amps mode and in 100 amps mode. Be sure to read the instructions and to switch the working mode of this, because the shunt and the working mode, they have to match. Then it will measure properly. So that's the only update I did to this controller. No, sorry, not the only one. The resistors is also different from the default one. So in my case, what I've noticed for the time that I've been using this kind of controller is that once it engages the brakes, and I must admit that I really like how it works with the brakes, because it engages it exactly for the number of seconds as long as it's needed. Unlike these guys, if the brake is engaged here, for example, it's for 10 minutes, and you cannot do anything, you cannot stop it, you cannot resume it, reduce it, whatever, 10 minutes and shut up. Here, only for the number of seconds once the voltage is over. So, for example, the battery reached the voltage, the wind turbine reached the charging voltage. I mean, the controller transformed it by his modules to the voltage that is over the expected limit. Then the the resistor is engaged. You can clearly see. I cannot see it now, but on this place somewhere, the resistor sign appears, right? And in that case, you are able to locate it, to see it. And then what happens after the voltage goes down? It immediately releases the turbine back to action. Amazing, absolutely amazing. And I mean, the only thing that I've noticed that since it was having the 1 ohm resistor, the default one, it was really pressing heavily on the wind turbine. So sometimes it even was doing like this extra drag sound even on the wind turbine. So that was a pretty hard hit for it. So what I decided is just like to double the resistor amount, and I put them in sequence, which means I reduced the ohmage, the resistance, not reduce, increase the resistance to be 2 ohms, which means this will be less amps on the given voltage. I mean, it will be very much lighter hit on the wind turbine, so it will be more gently pressing on the brakes, not like the full brakes engaged at that exact time. So let's go back now to the settings, because this is something that we have been interested in. I have this kind of thing prepared for myself from the instructions, so I'm not giving you anything extra. I'm just like giving you from the example. So how to work with this? You press enter, and then you press up and down if you want to change it. And then you press enter, keep pressing enter to circle between the elements, right? If you hit escape, you go back to the default screen. So that's it. If you hit enter, for example, the first is R under value. This means that this is the under voltage once the system will be kind of shut down. So this stuff should be generally technically somewhere around 48. So I'm just pressing the down button. Let's give it 47.5. I don't care. Then I press OK and I confirm it. Right? Then once I press one more enter, one more time enter, this is the U over. Oh, hold on. Sorry, I think I've missed something. Yeah, this is U under, this is R under. Ah, come on. I fooled you guys. So first value is U under. U under should be somewhere around 48. This is the voltage, the under voltage for the wind turbine. So okay. And R under means the voltage once it starts returning. Normally this relates to the load stuff, because this controller can have some load onto it, and this means that the load won't be engaged until this kind of value is reached back. Same applies to over voltage. 62.4 is way too high. I definitely have to put it somewhere to 59. Yeah, I know why this happened, because I've been switching with the batteries, so I'll probably have to do this one more time. But anyways, it's good that we can do all the settings here. So U over is set. Then R over, this means that this is the voltage once the normal working voltage will be returned. So this is basically the brakes engagement stuff. So I normally set this to be the voltage which is the charging, which matches the charging voltage for my system. So what else? BCV, this is the charging voltage for this thing. So this should be 57.6 in my case. Okay. Then float for lithium ferrum phosphate batteries is considered to be okay at 55. Sometimes 55.5. So check with your batteries manual, and that's it. Then next, oh come on, sorry, I missed it. Then the next is braking voltage for the wind turbine. So this is technically the max that is allowed. So let me reduce it a little bit, because I didn't want it to overspin. I don't know, I don't understand when exactly can it go to that high values, but technically you also have to check with the manual. There in the tables it clearly says what kind of voltages of wind turbine you can put into this controller. And normally the normal standard 48 volt wind turbine is okay absolutely for this one, because, well, this is the one that I have. Let me put it to be 80. I mean, this will still, anyways, how it works. It gets to the battery charging voltage and then keeps around it, and then it presses with the amps heavily. So let me have it at 80 for whatever reason. So this one relates to the load. I'm skipping it all because nobody of you will be using the load, literally. And then this is these last two are the most important things. So 1, 2, 3, 4 basically switches between the batteries. So 1 is for gel, like I have right now. 2 is for lithium ferrum phosphate. 3 is for NMC chemistry. And 4 is for custom settings. So let me switch back to gel. This is the number 1. And then I have to... under the second one, you see it went into error, right? In the second one, I have to put the number of batteries in series. And since I have 4, right, it considers, once working with gel, that each of the items is 12 volts. So I have to put this to 4 and confirm it. And then at some time, it will get back to OK status, right? You see? In some point, the error will go off. Yes, it does. That's it. That's when we are good and we can see the values are set to be absolutely nice. But since I'm going to use it with the lithium ferrum phosphate, and so will be you doing this, guys. So let me explain you how does it work with the other settings. So if here, for example, I will change this to lithium ferrum phosphate, and this is the number 2, I confirm it, I have to put again the number of batteries in series, and you see again it went into error. So since it considers 3.2 volts per cell, you have to enter the number of cells that you may have. And this is, in this case, 16. Oh, come on, 16. Sometimes in your batteries you may have 15, because it depends on the manufacturer. So just check with the specifications so you are aware. And yeah, I will put it to 16 and then confirm it, and it'll be absolutely... Okay, let me double check it, because I don't know if I did it. Because you have to normally do it quickly, not record. Yeah, it did. It confirmed, and then this went off, so I can go to escape, and then the system will be absolutely okay. This is it. This is it about settings, and there is nothing extra you should know about. Just like be sure to have this kind of document, which is the manual that you have, and you have to understand how the thing works, and overall everything else is considered to be okay. So again, I'm giving you the links to this controller. Just don't get it with Wi-Fi. Remember it. This thing is useless. Absolutely. Don't waste your money on it. And then I will give you the link to this exact wattmeter that I'm using, and I will give you also the link to the Tuya one, which is $10 more, which is twice more than this one. I mean, but that one has Wi-Fi, and that one can do all the job that is here, but cheaper. So, I mean, that's my recommendation. No Wi-Fi with Tuya Wi-Fi wattmeter. That's it. So let me know what do you think. I've been doing the review of this controller with all the ins and outs with the first launch some time ago, like about a year ago. I didn't know that much about it at that time because that was me doing that at first time. Now I have some kind of experience with working with it for a while. I mean, and I kind of like it. It's okay. It's very good. The only thing you have to also consider is that with solar, it works as a PWM controller, not as an MPPT. This one is MPPT for solar, but this one isn't. Absolutely not. But I mean, I don't care. I'm using it for a wind turbine, so that's the only difference. So thanks for now, and well, hope you like it. If you did, hit the like and subscribe button if you haven't yet. And yeah, follow me for more.